A web session is a sequence of HTTP request and response transactions between a web client and a web server, right? You have things like pre-authentication tasks, the actual authentication process, the session management itself, access control, and session finalization. Now, a whole bunch of web applications keep track of information about each user for the duration of the web transactions, right? So several web applications have the ability to establish variables like access rights and localization settings and many other settings, right? And many other variables. Now, those variables apply to each and every interaction a user has with the web application for the duration of the session. Now, web applications can actually create sessions to keep track of anonymous users after the very first user request. Now, for example, the actual application can remember the user language or the actual language preference every time that user visits the site or an application front end. Also, web applications use sessions once the user actually has authenticated, and this actually allows the application to identify the user or any subsequent request, and also be able to apply security access controls to increase the usability of the application. So in short, web applications can provide session capabilities both before and after authentication. Now, once an authenticated session has been established, the session ID or the token is temporarily equivalent to the strongest authentication method used by the application. Things like the username and passwords and one-time passwords, client-based certificates, and many others. Now, a good resource that I actually want to share with you that provides a lot of information about application authentication is the OWASP authentication cheat sheet. And I have the link here in the screen. So, again, become familiar with it. It's actually an amazing group. As I mentioned before, OWASP is just amazing. They have tons of resources, and this cheat sheet actually has a lot of very valuable information, right? So, but let's actually go and deep dive into some of these authenticated or session management elements. Now, in order to keep the authenticated state and track the user's progress, applications provide users with a session ID or a token. And this token is assigned at the session creation time and is shared and exchanged by the user and the web application for the duration of the session. Now, that session ID is a name-value pair. Now, session IDs used by the most common web application frameworks can be easily fingerprinted. For example, you can easily fingerprint a PHP session ID or PHP SES ID, and of course, that that it's a PHP development framework behind it. You also have things like a JSession ID that is actually used with J2EE, and CFID and CF token that is actually used for Cold Fusion, ASP.NET session ID, and of course it's actually used by ASP.NET and many, many others, right? Now, another things that you can actually see from the session ID is probably what framework and programming language are actually used by the web application. Of course, in the PHP example, that's a given, but in the J2EE, that's actually most definitely a Java application, and so on. Now, that is why it is recommended to change the default session ID name of the web application framework to something generic, right? Something like just ID, right? And that avoids, of course, for somebody to easily fingerprint those names, right? Now, the session ID must be long enough, so the actual ID must be long enough to prevent brute force attacks, right? Sometimes developers actually set to just a few bits, but generally they must be at least 128 bits or 16 bytes. It is very important that the session ID must be unique and unpredictable. That's a given, and this is why you need to use a good pseudo-random number generator or PRNG, and the session ID value must provide at least 64 bits of entropy if a good PRNG is actually used. Now, there are multiple mechanisms available in HTTP to maintain session states within web applications, like cookies, in the standard HTTP header, URL parameters, and rewriting defined in RFC 2396. You also have URL arguments on GET request and many others. Now, developers also use body arguments on post requests like hidden form fields or HTML forms or proprietary HTTP headers. However, one of the most widely used session ID exchange mechanisms are cookies. And this is because cookies offer advanced capabilities not available in any other method. Now, one malpractice, not a best practice, but a malpractice that you can take advantage of whenever you're doing a penetration testing is when the session ID is included in the URL. This flaw can actually lead to the manipulation of the ID or session fixations attacks. Now, web development frameworks like ASP.NET, PHP, Ruby on Rails, Django, and many others provide their own session management features and associated implementations. This is recommended, and it's actually definitely recommended to use built-in the built-in frameworks instead of actually building your own from scratch, since they can actually be tested by many people. And often, actually see many developers actually trying to create their own in many environments, and then you actually find that they are not secure by any means, right? So whenever you're, doing pen testing, if you actually find some of these custom applications, pay attention into, how the session IDs are actually being exchanged, and if they're actually creating their own cookies or they're perhaps are susceptible to session fixation attacks. Now, this is pretty obvious, right? You have to remember to encrypt the entire web session, not only for the authentication process where the user credentials are exchanged, but also to ensure that the session ID and all other elements are actually only exchanged through an encrypted channel, right? So it is extremely obvious, but you will be surprised the number of applications that actually are only encrypting the initial session, right? Or that, some elements of the applications are actually not going through an encrypted channel. Now, the usage of an encryption communication channel also protects the session against some session fixation attacks. This is whenever the attacker is actually able to intercept and manipulate the web traffic to inject or quote-unquote fix, right? That's where the session fixation name comes in. So they actually are able to inject or fix the session ID on the victim's web browser. Now, session management mechanisms based on cookies can make use of two types of cookies: non-persistent cookies, or what we call session cookies, and persistent cookies. So if a cookie has the max age or the expires attribute, it is considered a persistent cookie, and it will be stored on disk by the web browser until the expiration time. Now, one quick note is that the max age has that element has a preference over the expires attribute. Now, typically modern applications track users after authentication using non-persistent cookies. This forces the session information to be deleted from the client if the current web browser instance is actually closed. This is why it's important to use non-persistent cookies so that the session ID doesn't remain on the web client cache for a long period of times. So session IDs actually must be carefully validated and verified by the application. Depending on the session management mechanism that is actually used, the session ID will be received in a get or a post parameter, or it can be in the URL or in an HTTP header using cookies. Now, if web applications do not validate or filter out invalid session ID values, they can actually also be potentially be exploited by other vulnerabilities like SQL injection, if the session IDs actually are stored on a relational database, or persistent cross-site scripting, if the session ID are actually stored and reflected back afterwards by the web application. Now, you will learn a lot about SQL injection and cross-site scripting later in the course.